Hello, 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 everybody, and welcome back. Root Beer here, of course, looking at more of the 2016 Open Contest. We just looked at C1 in the last video, and now we're up to C2. So let's see what we've got here. Alice and Bob play a game. Okay, they take turns. They play on a row of N seats. On a player's turn, he or she places a coin on any seat, provided there is no coin on that seat or on an adjacent seat. Alice moves first. That's usually what happens. The person with the earlier alphabet name goes first. The player who does not have a valid move loses the game. So now we understand the loss condition, and it just keeps going back and forth. Alice, Bob, Alice, Bob. Alright, it's an interesting little game, and it looks like all three of our questions, just at a glance, are the same. Show Alice has a winning strategy when N is 5. Show Alice has a winning strategy when N is 6. Show Bob has a winning strategy when N is 8. Okay, so ordinarily with a game-style question, I would probably recommend try and keep the elements of the game the same, but reduced to a smaller case. But 5, 6, and 8, these are already pretty small, so I think the easiest thing to do is just start playing the game with ourselves. They're even telling us who should be winning. Alice, Alice, and then Bob when it's 8. So we just need to take a look at those and start playing around. I'm not going to use seats. I'm just going to sort of have a row of 5 things and say, okay, if Alice has a winning strategy, she should have this one move that she makes, and then no matter what Bob does, she should have a follow-up, and so on. Okay. So, let's get the last question out of the way, and we'll take a look here. Okay, so, we'll start playing. So, what could Alice do? Well, I'm going to use A for Alice's move and B for Bob's, and I'm just wondering, okay, if Alice plays in the middle, what can Bob do? Now, as soon as that is played in the middle, Bob couldn't play a coin, and Alice can't play a coin either on either side of this A, so that just leaves 2 spots open. Bob could pick one. This doesn't eliminate any new spots, and Alice could play the next one, and then Bob is stuck because he can't play anywhere else. And I suppose vice versa. If Bob went here, Alice went here. So, well, that was a nice lucky guess, just planting it right in the middle. So we should probably write that up a little bit. But I'm more curious to see how 6 is going to change this here. Alright, so Alice's first move. And there might be other strategies for this. This is just the one I stumbled on first. Alice should place her first coin in the middle, and it's also helpful for games like this to actually, as you're writing out the instructions for the winning strategies, to show off what's going on. That way the person who's marking has a clear visual idea as to what's going on. So place her first coin in the middle. This, and I'm going to color code. This eliminates the 2 adjacent, they call them seats, I guess, seats for placement. So if we number these, Bob can place his coin on seat 1 or 5. Alice's next move, and so I would show them Bob's 2 possible. So Bob could place here, or Bob could place here. Alice's next move is to play in the other spot. So we keep the pieces the same. So it went Alice, then Bob, then Alice here. Here we've got Alice, Bob. Alice wins, as Bob has nowhere to place a coin. And we've already explained why that is, and we could keep the eliminated squares around with us if we wanted to, just to try and make it really clear that yes, we understand these squares here are always off limits. Alright, so that's 5. The next one, Alice should win when we've got 6 as well. So we'll play around. Hopefully I'll have a bit more to play around with, just more to show off to you guys. And maybe I won't stumble onto it immediately. Although, knowing Alice's strategy in the previous one, placing in the middle, could Alice win again by placing in the middle? So what does that do? That eliminates a few spots. So if Bob places here, Alice could place either one of these will do. But Bob also has these 2 spots to go as well. So Bob could place here, and his coin would eliminate this one, as well as this one again, but it's already eliminated, so it doesn't matter. And then Alice could still freely play here as well. And same thing if Bob placed his coin here. All that does is eliminate this spot, but this one over here is still wide open for Alice. So basically the same strategy. So I'm going to say number the seats 1 to 6, and I'd probably show them a little picture as to what I mean. Alice should play 3 or 4. I mean, it's going to be a symmetric picture, but I'll just say Alice should play on 3. This eliminates 2 and 4, leaving 1, 5, or 6 for Bob. Okay, so a little picture of what we've got going on so far. Okay, remember, this is a C-part question. We do have to actually explain and show what's going on and make it readable for the markers. So we'll just break out down our strategy. If B plays on 1, A plays on 5, eliminating 6, and wins. Draw a quick little picture of that. So B on 1, A on 3, A on 5. We'll keep the red going just because we've already got it. Okay. If Bob plays on 5, which eliminates 6, A plays on 1 and wins. I'll draw a quick little picture of that. So A, B, A. I'll fill in the red X's in a moment. 6. So if Bob plays on 6, this eliminates 5. Might put these in brackets just to make it a little more readable. A plays 1 and wins. A, but now B's over here. So it seems like if you divide by 2 and round up, maybe that if that's even or odd, you might get Alice winning or Bob winning or something like that, which might help me for 8. And I'm just trying to plan ahead for 8 based on what we've seen. Because the question says, show that Bob has a winning strategy. Oops, that was supposed to be an underline. Show that Bob has a winning strategy when n is 8. So let's just play around with it. Okay. Alice gets to play first, so that's a bit trickier. There's lots of plays Alice could make. This is going to be 1 based on each one. So once again, I would probably... Well, actually, I'd probably say this to the markers. I write this down, so... Number the seats 1 to 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. There is symmetry in the strategy. I don't want to have to deal with Alice plays at 1, and Alice plays at 2, and Alice plays at 3, and Alice plays at 4, and then also have to deal with Alice playing at 5, because Alice playing at 5 is the same as Alice playing at 4. Just do mirror images. So a quick line about symmetry or mirroring your argument is going to save you some time in the write-up, and we want to leave time for C3 and C4. So there's symmetry in the strategy. So we'll only handle Alice playing in 1, 2, 3, or 4. You could say something like 5, 6, 7, 8 are handled with mirror arguments. People marking will know what you mean. Okay, so what if Alice plays... Okay, now I haven't developed a strategy for Bob at all, but I know that any strategy that we write up, any winning strategy, will have to break down like this because Alice plays first and we don't know what she's going to play. And a winning strategy is one where, regardless of how Alice plays, Bob can win. Okay, so if Alice plays 1, what are we looking at? Now is the time I'm going to play around. So Alice plays here. This eliminates 2. And then... Well, this leaves 6 left over, so... This leaves 6 seats in a row with Bob to play. And by our work in B, so in B we said Alice will win if it's just 6 seats, if N is 6, but that's because Alice played first. So by B we know if N equals 6, the first player wins. So Bob wins, and then I would just say something like CB for the strategy. You could, if you wanted to, just reproduce everything we wrote for the B. I mean, there's not that much here, but why waste your time? Okay, why waste your time? You say, I already wrote up the strategy, CB for how it works. That's what we're interested in. Alright, what if Alice plays at 2? Well, now this eliminates 1 and 3. But I think that's just going to leave us with 5, which is what happened in A. 3, 4, 5, 6, 7. So Alice plays here. Yeah, we're just left with 5 again. So this leaves 5 in a row. CA, where the first player, which is now Bob, has a winning strategy. So that's nice. These cases here, they sort of boil down to some earlier stuff. Now, I don't think the same thing's going to happen with Alice playing at 3 or at 4, just because it won't be broken into a single chunk. So here we actually do have to do a little bit more work. So Alice plays 3. This eliminates 2 and 4. Alice plays here. And so now we've got a question, what can Bob do? So I'm really tempted to have Bob play over here. And so that's not going to eliminate anything. And then Alice can play in one of these 4 spots. She plays here, Bob plays here. She plays here, Bob plays here. If she plays here, Bob plays here. If she plays here, well, Bob could play there, but I think for symmetry's sake, I'll have Bob play here. So I think, yeah, that seems reasonable. Just have to write that up. So let Bob play at 1. Actually, I'm going to color code this, so I can add this up here, and I don't have to keep redrawing my entire picture. This leaves 5, 6, 7, 8 for Alice. So, and we can just make a little chart. If Alice plays 5, Bob plays 7. If Alice plays 6, Bob plays 8. And so on. In fact, it really doesn't matter. Just wherever Alice plays, Bob will get another play. Okay? So, nothing else really to say beyond that. There are other options, like if Alice played 8, I guess Bob could play 6. He could also play 5. Doesn't really matter. Should you draw pictures for each of these? I guess if you have time, but if you've been drawing pictures consistently, I'm fairly certain that, and as long as you write this part out here, very nice and neat, whoever is marking is going to trust. Yeah, they know what they're talking about. They've looked at the cases. But if you want to write out a picture for each one, that would be a great thing as well. Just, you have to learn to manage your time. Alright, so the last situation, Alice plays 4, and this eliminates 3 and 5. And again, I think we're going to have Bob play in the little pocket area, maybe. So Alice plays 4. So if Bob plays over here, that eliminates that, but then Alice could play here, eliminating those 2. So we don't want that. I think if I have Bob play here, so 6, 7, 8, 1, 2. If Bob plays here, that eliminates that, but this is left open. Now Alice either plays there, and then Bob plays in one of these, or Alice plays in one of these, eliminating the other, and then Bob plays in here. Okay, alright, good strategy. This is not as hard a game theory question as it may have first looked, because they actually tell us who's going to win. So we just need to, when confronted with Alice's different options, tell them what Bob can do. We're not hunting to determine who's going to win for what stretch of n seats. Okay, so we'll say have Bob take 6, eliminating 7. Bob goes here. If Alice plays, then Bob plays. So if Alice plays 1, have Bob play 8. And you can even have another column here, eliminates. So 1 eliminates 2. If Alice plays 2, that eliminates 1. Again, have Bob play 8. If Alice plays 8, that eliminates nothing. And have Bob play. It doesn't matter which one, so we'll say 1. Actually, I'll say 2 just to, because then the picture would be all the evens are taken. Okay. But there we go. We've handled every possible Alice case. As I already mentioned, don't have to do 5, 6, 7, and 8. Okay. So So no matter Alice's play, we see Bob can win. Following this combined strategy. Now I say combined strategy because I didn't write out the full strategy. I said, hey, you can check A and you can check B. Just change Alice's name to Bob's name and so on. This combined strategy. Well, there we go. So, there wasn't a D part, so we're all done, and that finishes up C2. Up next, of course, C3. So if you're looking for more of the 2016 paper, I will see you for that in the next video.